Good morning everyone. Today in this live lecture we shall learn the new type of a special function, and that special function is beta function. In the previous lecture we have studied the gamma function. Actually these are the two Eulerian special functions, Eulerian integrals. These are the special integrals. So this is the first kind of integral, that is a beta function, Eulerian first kind integral. Okay, see this. Actually here we have to learn here beta function, then remaining part we shall discuss. Okay, now actually according to the gamma function we have seen the Eulerian integral, which are also known as a beta function and gamma function. Eulerian special integral first kind integral is known as a beta function, and Eulerian second kind integral is known as a gamma function. So this is the definition of a gamma function, and some properties we have discussed in the gamma function. Okay, in the yesterday we have seen this important property, gamma of 1 by 2, which can be obtained by root pi by 2. The value of gamma 1 by 2, which is given by root pi. See this, gamma 1 by 2 means actually the value of gamma 1 by 2 is root pi, you must know. So we can write 2 times of integral from 0 to infinity e raised to minus x square dx. It is also represented by the value of this integral is also denoted by root of pi. Okay, root of pi. Now first of all, before starting the gamma beta function, first of all we shall discuss the problems based on this function. That is, we have to find out the value of gamma root 3 by 2, gamma 1 by 2. Okay, so first of all we shall discuss the problems and then we shall move towards the gamma function. Okay, now how we can find the value of C here? 1 minute. Problems. First, evaluate gamma of 3 by 2. So we can use the gamma of 3 by 2. Answer, we have gamma n means n minus 1, gamma n minus 1, or you can use n, gamma of n plus 1 is equals to n gamma n. So 3 by 2, so therefore gamma 3 by 2, that can be written as 3 by 2 minus 1. Who can tell me what is the value of 2 by 3 minus 1? 3 by 2 minus 1, because n is a 3 by 2 here. So 3 by 2 minus 1, 3 by 2 minus 1, that is the value of 3 by 2 minus 1 is 1 by 2. So 1 by 2 gamma of 1 by 2, that is 1 by 2 gamma 1 by 2 means we can write root pi. So the value of this is root of pi by 2. Second, this is the first problem, that is evaluate gamma of 3 by 2. Okay, साईनाथ सेवारे, श्रद्धा डुकरे, ऐश्वर्या नाडे, ओंकार सुरोशे, मदिहा, ठीक है. Okay, now evaluate gamma of, suppose 9 by 2. Again we have to calculate, we have, what is the formula? We can write gamma n plus 1, which is equals to n gamma n. Therefore now we can calculate gamma n plus 1, gamma of 9 by 2, which is equals to 9 by 2 minus 1 into gamma 9 by 2 minus 1. 9 by 2 minus 1 means we can write this as a 7 by 2 gamma of 7 by 2. Again we can write 7 by 2 into, now see here, gamma 7 by 2 means we can write gamma n plus 1. Then decrease that to 7 by 2 by 1. 7 by 2 minus 1 means 5 by 2 gamma of 5 by 2. So we can write which is equals to 7 by 2 5 by 2. Again we have to write the value of gamma 5 by 2. Gamma 5 by 2 means we have to decrease 1. 3 by 2 gamma 3 by 2. So it will be, we can write 7 by 2 5 by 2 3 by 2. Again gamma 3 by 2 means 1 by 2 gamma 1 by 2. That means we can write 7 into 15 divide by 2 raised to 4 gamma 1 by 2 gamma of 1 by 2. That means, so 105 divided by 16 gamma 1 by 2 means root pi. Is it okay? Therefore we can write gamma of 9 by 2 which is equals to 105 root pi divided by 16. This is the value of gamma 9 by 2. In this way we can obtain the value of gamma of positive non-integer values. We can find the gamma of positive non-integer values. Okay. Also we can find the negative non-integer values. So evaluate gamma of minus 1 by 2. Okay, we have to calculate a gamma of minus 1 by 2. So we have gamma of n that can be written as n minus 1 gamma n minus 1. But if we use gamma minus 1 by 2, then we cannot find the value of gamma minus 3 by 2 in this way. But we have the value of gamma 1 by 2 we have. Therefore now you use the formula gamma 1 by 2. In place of n put 1 by 2, gamma 1 by 2 which is equals to 1 by 2 minus 1. 1 by 2 minus 1, that will be minus 1 by 2. So we can write minus 1 by 2 gamma of minus 1 by 2. That means if we put 1 by 2 here, because we know that the value of gamma 1 by 2, that is root pi, which will be minus 1 by 2 gamma minus 1 by 2. Is it okay? Actually we have to find out the value of gamma 1 by 2. So you can take this on left side. So minus हे division मधला 2 multiplication मध्ये 2 root pi which is equals to gamma of minus 1 by 2. So we can write gamma of minus 1 by 2 which is equals to minus 2 root pi. Thus we can obtain the value of gamma 1 by 2 minus 1 by 2 from gamma 1 by 2. Okay. Similarly we can find next third, evaluate gamma minus 3 by 2. How we can write the gamma of minus 3 by 2? Again we can find this value Again we can find this value by using gamma 1 by 2. We have actually, what is that formula? Gamma of n plus 1, which is equals to n into gamma n. You can use alternatively formula gamma n is equals to n minus 1 into gamma n minus 1. म्हणजे इथं जी काय टर्म आहे त्याला 1 न डिक्रीज करा. मग आता गामा माइनस 3/2 अगर कैलकुलेट करना है तो यू हैव टू स्टार्ट फ्रॉम गामा. नाउ gamma 1/2, you know the value of gamma 1/2. What is the value of gamma 1/2? Gamma 1/2 means as like this, gamma n minus 1 means minus 1/2 gamma minus 1/2. Again we can write minus 1/2 into, again you have to use gamma minus 1/2. Use this formula, gamma of n plus 1 is equals to n into gamma n. So we can decrease this. Gamma minus 1/2 means minus 3/2 gamma of minus 3/2. So we have to calculate this value. So minus, we can put gamma 1/2 means root pi. So root pi minus minus plus 3/4. See this, 3/4. We can write this as किती येतं बघा, 3/4 into gamma of minus 3/2. Is it okay? व्हेरी गुड. तर आता या ठिकाणी गामा 3/-3/2 ची किंमत कॅल्क्युलेट करा. म्हणजे हे रेसिप्रोकल घ्या इकडं. सो इट विल बी 4 root pi divided by 3. Is it okay? Which is equals to gamma of minus 3/2. So we can write gamma of minus 3/2, which is equals to 4 root pi divided by 3. In this way. Is it okay? In this way we can obtain the value of gamma for the negative terms. Okay. Next we shall move towards the 4. Also we can find the gamma of 5 minus 5/2. We can find the value of a gamma which is a positive or a negative, but it must be non-integer value. If the non-integer value having a denominator 2, if a fraction having a denominator 2, then we can write its value in terms of a pi, in terms of root pi, unless we can't find. See this, denominator of each term here 2, 5/2, minus 3/2, 1 minus 1/2, here 3/2, here. In this way we can find 9/2, means denominator having a 2. Then we can write the value in terms of root pi. Okay. So now 5/2 we have to find, we have to calculate root of gamma minus 5/2. Now see this, we have, what is the formula? Gamma of n is equals to n minus 1 gamma n minus 1, but we have to start this with root 1/2. Now gamma of 1/2, which is equals to minus 1/2 gamma of minus 1/2, that can be written as a minus 1/2. Again we have to use, here we know that gamma 1/2 means root pi. Now minus 1/2, gamma minus 1/2, again we have to use the formula gamma n is equals to n minus 1 gamma n minus 1. That means minus 1/2 minus 1, that will be minus 3/2, minus 3/2 gamma of minus 3 by 2. So it will be minus minus plus, that is 3 by 4 into, again we can use the gamma. आता ठीक आहे, तुम्ही इथं सिक्वेन्स लिहा, पुन्हा कॅल्क्युलेशन करा. दॅट मीन्स गामा मायनस 1 by 2, gamma minus 3 by 2 into, again we have to use the gamma minus 5 by 3 by 2 minus 1 means minus 5 by 2 minus 3 by 5 by 2, gamma of minus 5 by 2. So this minus 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 plus plus into minus means minus. This is the left side is root pi, that is a 15 divided by, किती होतं रे पहा, 15 divided by 8. Is it okay? 15 divided by 8 into, बरोबर आहे का रे स्टुडंट्स, into gamma of minus 5 by 2. We have to calculate this. Now transfer on left side, therefore 8 root pi divided by 15, and ha minus, you can take this minus, which is equals to gamma of minus 5 by 2. So we can write gamma of minus 5 by 2, which will be minus 8 root pi divided by 15. Is it okay? So this is the required value of gamma minus 5 by 2. That means we can find any fraction whose denominator is 2, it may be positive, it may be negative, gamma of any fraction, it may be negative, it may be positive, whose denominator is 2, then we can find its value in terms of root pi, gamma of that function in terms of root pi. So you can calculate this homework. 3, 4, 5, okay, 6. You can take this homework. Gamma of 11 by 2, gamma of 7 by 2, gamma of 15 by 2, gamma of 13 by 3. See this, for this we can't find the value in terms of root pi, but we can write in the gamma function, simplified gamma function. We can find the value of this in the simplified gamma function. This is the 9th number problem, because in the denominator there is a 3. Now we can write 10 gamma of, suppose 15 by 2, 11 gamma of minus 7 by 2, 12 gamma of minus 9 by 2. So gamma of minus 15 by 2. Now these are the negative terms. We have to calculate the value of this gamma negative fraction whose denominator is 2, which is starting from, starts from gamma 1 by 2. So okay, you can calculate, solve all these problems is like this. Okay, and you have to solve this problem number 9. We have solved previously this example. Okay, now you have to solve all these problems. सोडवतात ना ऐश्वर्या नाडे, सेवारे, कारभारी, माने. प्रॉब्लेम डबल झाला का? 15 by 2 झाला का? ठीक आहे, झाला असेल तर. नाही झाला, 15 by 2 नाही झाला रे. 15 by 2, अच्छा कुठं आहे? ओके ओके. सो आय शॅल गिव चेंज, इट विल बी, वी शॅल चेंज 13 by 2. Okay, now we shall move towards the next function, that is a beta function. This is the beta function. Now we shall define the next function, the beta function. So how we can define the function? The first Eulerian integral which are also called beta function, and it is denoted by beta of m comma n, beta of m comma n किंवा बीटा m comma n, बीटा mn, बीटा m comma n. कसं वाचायचं? बीटा m comma n. This is the special type of a function, Euler's special integral, and is defined as so beta of m comma n, which is equals to, we can write integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. And here m comma m is greater than 0, n is greater than 0. As like a gamma function we can write. This beta function, this is the Eulerian first integral. Eulerian first integral, which is also called beta function, and it is denoted by beta m comma n and is defined as beta m comma n. It reads, आता ह्याला कसं वाचायचं? Beta m comma n is read as beta m comma n. कसं वाचायचं? Beta m comma n. Now this is actually Eulerian integral. This is a Eulerian special integral. This is also called as a beta m comma n. It is also known as a beta function, but its limit is from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. That is integration with respect to x. We can define the beta function with respect to y, with respect to t in the different variable form. Also we can write, also we can define say this, also we can write beta m comma n, which is equals to integral from 0 to 1, we can write in terms of x. So that means y raised to m minus 1 into 1 minus y raised to n minus 1 dy. That means in terms of y, beta m comma n, which is equals to integral from 0 to 1 y raised to m minus 1 into 1 minus y raised to n minus 1 dy. Here also m comma n greater than 0. Also we can write in another variable t, beta m comma n, which is equals to integral from 0 to 1 t raised to m minus 1 into 1 minus t raised to n minus 1 dt. Main काय पहा, see this, main m, so we have to write here m minus 1, and n, so we have to write here n, म्हणजे 1 minus x raised to m minus n into 1 minus x raised to n minus 1 dx. This is the main formula, and we can write in terms of dx, in terms of dy, in terms of t, whatever may be. Same condition which we have to take. See this, okay? So this is the definition of a beta function, beta m comma n, which is equals to integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx, where m comma n greater than 0 series. This is the definition of the beta function. Now here we shall write the value of this beta function in terms of different types, okay? याला आपल्याला प्रॉपर्टीज आपण बीटा फंक्शनच्या लिहू शकतो, ट्रान्सफॉर्मेशन्स लिहू शकतो आणि बेसिक प्रॉपर्टीज लिहू शकतो बीटा फंक्शनच्या, ओके? So we can write the properties of beta function. हे लक्षात येतं का? व्हेरिएबल चेंज करून लिहा. स्नेहल भोसले, एवढ्या उशिरा जॉईन नाही व्हायचं, उगा जॉईन व्हायला म्हणून प्रेझेंटी टाकायला म्हणून येते का? हा, फर्स्ट इयरच्या विद्यार्थ्यांना स्ट्रिक्टली सूचना आहे बघा, मी हॉल तिकीट देणार नाही. जे विद्यार्थी ॲब्सेंट राहतील ना ऑनलाईन लेक्चरला, हॉल तिकीट देणार नाही मी, लक्षात घ्या. परीक्षेला बसू दिलं तर हॉल तिकीट देणार नाही मी, लक्षात ठेवा. दुसऱ्या सेमिस्टरला परीक्षेला बसू दिलं जाणार नाही. ओके, नाउ वी शॅल मूव टुवर्ड्स द नेक्स्ट properties of a beta function. Properties of a beta function, or basic property which we have to discuss. See this, prove that beta m comma n, that can be written as beta n comma m. That means we can interchange m and n. See this, we can interchange m and n. There is no any problem. We can interchange m and n. आता इथं जर लिहिलात, how we can define beta of m comma n, we can write. आता ह्याला जर बीटा n comma n लिहायचं आलं तर कसं लिहिलं जातं पहा, बीटा ऑफ m comma m is equals to, we can write this. Okay, now we can move towards, in place of n we can write this. We have to show that m and n are symmetrical in the beta function. M and n are the symmetrical in the beta function. That means we can interchange m and n. We can interchange m and n. So we shall move towards the formula proof. See this, we have, by definition of beta function, what is the definition of the beta function? Beta of m comma n, which is equals to integral from 0 to 1 x raised to m into 1 minus x raised to n, m minus 1, 1 minus x raised to n minus 1 dx. This is the beta of m comma n. Okay. So we can write this equation number 1. Also beta of n comma n, we can write n comma m, means we have to interchange this integral from 0 to 1 x raised to n minus 1 into 1 minus x raised to m minus 1 dx. Suppose this is a second. Now what we have to prove? Now we have to prove beta m comma n, which is equals to beta n comma m. Now from 1 we have beta m comma n, which is equals to integral from 0 to 1 असं करू, डायरेक्ट प्रॉपर्टी वापरू. From 1 we can use the property of definite integral. We can use the property of definite integral. What is that property of definite integral? Integral from 0 to 1 f of x dx, which is equals to 0 to a. We know that property in the definite integral. as करू, for integral 1, for integral 1 we have to use the property of definite integral. We can use it, USE. We can use the property. What is that property? Integral from 0 to a f of x dx, which is equals to integral from 0 to a. Who can tell me what is the property? We have studied this. 0 to a f of a minus x dx, f of a minus x dx. Okay, integral from 0 to a f of x dx, which is equals to, अरे साईनाथ सेवारे, जे विद्यार्थी आन्सर द्यायला लागले तेवढ्याच विद्यार्थ्याचे नाव लिहून घ्या. आपल्याकडे फक्त 13च विद्यार्थी दिसतात, 48 विद्यार्थी आहेत, आणि जे आज प्रेझेंट आहेत त्याचे नाव लिहून माझ्याकडे पाठव. बाकीच्यांना मी हॉल तिकीटच नाही देणार. आज जे प्रेझेंट आहेत, जे आन्सर द्यायला लागले त्यांचे नाव लिहून घे. नाउ वी हॅव टू यूज दिस प्रॉपर्टी फॉर द इंटिग्रल फर्स्ट. दॅट मीन्स बीटा ऑफ m comma बीटा m comma n is equals to integral from 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx. So we have to use this property. We have to use this property integral from 0 to a for the integral first. So therefore beta m comma n is equals to integral from 0 to 1. काय करायचं? x च्या जागी a minus x. a means upper limit 1. So we can write in place of x 1 minus x bracket raised to m minus 1 into, again x च्या जागी 1 minus x. 1 minus x means 1 minus a. So we can write this as 1 minus x च्या जागी 1 minus x bracket raised to n minus 1 dx. So this can be written as integral from 0 to 1 1 minus x bracket raised to m minus 1 into 1 minus 1 plus x bracket raised to n minus 1 dx. So we can write integral from 0 to 1 1 minus x bracket raised to m minus 1 into x raised to n minus 1 dx. That is equals to integral from 0 to 1. You can write first this x raised to n minus 1 into 1 minus x raised to m minus 1 dx. But we can write according to the definition of beta function, or by using the equation second, integral from 0 to 1 x raised to n minus 1 into 1 minus x raised to m minus 1 dx, we can write beta of n minus 1. So we can write beta n minus n. This is a from second, from equation second. Thus, therefore, beta m comma n can be written as beta n comma m, and hence proved. Also, we can find the values of beta function. So, this is one property. Now, also we can write the value of beta function. Proof ची गरज नहीं है. So, we can write the beta function in the form of second. The value of a beta function, the value of a beta function, evaluation of beta m comma n, we apply integration by parts. So we can write the value. मी direct लिहितो. So this is the first value. Integration by part वापरायचं right side ला. That means the reduction formula. We have to use the integration by part on the right side. First as it is integration of second minus in integration derivative of first integration of second. Proof is not so important, so we have to write only the value number 1 beta m comma n, which can be written as, so n minus 1 factorial divided by so we can write m plus 1, m plus 2 dot 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 m plus n minus 1. This is when n is positive. n positive असेल तर second, we can also write m जर positive असेल तर beta m comma n, which is equals to m minus 1 factorial divided by n plus 1, n plus 2 dot 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 n plus m minus 1. This is the second value. Condition कुठली आहे इथं? Since m is positive, m जर positive असेल तर means we can use the integration by part by interchanging u and v. एक वेळा u x raised to m minus 1 ला u घ्या आणि v दुसऱ्याला घ्या. दुसऱ्या वेळेस काय करायचं? u 1 minus x raised to n minus ला u घ्या and v. That means by interchanging u and v, we can get these two formulae. Now third, if both positive, दोन्ही जर positive असतील, beta m comma n, which is equals to m minus 1 factorial divided by n minus 1 factorial divided by n minus 1 factorial divided by m plus n 1 minute m plus n minus 1 factorial. Since m comma n are positive, दोन्ही पॉझिटिव्ह असतील तर हे फॉर्म्युले फक्त लक्षात ठेवा. याचं प्रूफ वगैरे तुम्हाला गरज नाही आहे. Actually this is the evaluation of the beta m comma n. How to calculate the value of beta m comma n in the form of a factorial. Okay. Now next we shall move towards the third condition. Now we can find the transformations of beta function. That means we can write beta function in the another integral form. We can find the beta function in the another integral form. To prove that इंटिग्रल फ्रॉम, हाँ सर्वांनी जे प्रेझेंट आहेत त्यांनी यस म्हणून प्रेझेंटी टाका रे. साईनाथ शेवारेला प्रेझेंटी घ्यायची आहे. ओके. प्रूव्ह दॅट बीटा ऑफ m कॉमा n which is equals to integral from 0 to infinity y raised to n minus 1 divided by 1 plus y raised to m plus n into dy. So this is another form of a beta function. This is the another form of a beta function. ओके. साईनाथ शेवारे स्क्रीनशॉट घेऊन ते पाठव प्रेझेंटीची. We have, by the definition of beta function, so beta of or beta m comma n is equals to integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. Okay. So now we can write this in the form, याला कसं लिहिता येईल पहा आता. सबस्टिट्यूशन मेथडनं रिप्लेस करायचे आहे. सो पुट x is equals to 1 divided by 1 plus y. So it will be dx is equals to minus 1 upon 1 plus y bracket square into dy. Actually 1 upon f of x चा derivative minus 1 upon f of x square into f dash of x. In this way 1 upon x चा derivative minus 1 upon x square. Okay. So we have to convert this integral. x चे इंटिग्रल y मध्ये रिप्लेस करायचे आणि 1 upon 1 plus y आहे. Actually we have to prove this. Integral from 0 to infinity y raised to n minus 1 divided by 1 plus y raised to m plus n means we have to convert in the new form of beta function, in the new form of integral 0 to infinity y raised to n minus 1 divided by 1 plus y raised to m plus n. So for this purpose we have substituted x is equals to 1 upon 1 plus y. Then dx is equals to minus 1 upon 1 plus y square dy. Limits also we can change the limits when x is equals to 0. देखो अभी लोअर लिमिट x is equals to 0 है. x की जगह पे आप अगर 0 रखते हैं तो y की वैल्यू क्या होते हैं. देखो मैं यहाँ पे सॉल्व करके दिखाता हूँ. इफ वी पुट x is equals to 0 then एक्चुअली कसा आहे पहा है, x is equals to 1 plus y. If we put lower limit x is equals to 0 then 1 upon 1 plus y. So you can take the reciprocal. We have to calculate the value of y. So reciprocal means 1 upon 0 is equals to 1 plus y. So 1 upon 0 means infinity. Actually 1 upon 0 tends to infinity, meaningless. So it is equals to 1 plus y. That means y is equals to infinity minus 1. So y is equals to infinity. This tells us that when x is equals to 0, then according to our substitution, y tends to 0. Y tends to infinity means y is equals to infinity. Actually meaning of this is as x tends to 0, then y tends to infinity. This is the concept of limit. Jari y is equals to infinity, actually in the scientific language, it is not correct to write y is equals to infinity, because infinity is not a perfect value. But meaning of this is y tends to infinity. जहां पर भी कहां पर भी infinity equals to आता है, तो इसका मीनिंग होता है that means that tends to infinity. ओके, अभी अपर लिमिट देखो, when x is equals to 1, then अभी अपर लिमिट लिखना है. अभी यहाँ पे 1 is equals to 1 upon 1 plus y, रेसिप्रोकल क्या 1 upon 1 which is equals to 1 plus y divided by 1, so y is equals to 0. 1 minus 1 means 0. Thus we can obtain the upper limit as a 0. Y is equals to 0. So we will write this integral, I shall write this integral in the form of y according to our substitution. So left side as it is beta m comma n, which is equals to integral from infinity to 0, because these are the new limits. Now what is mean by x? In place of x you have to put 1 upon 1 plus y. So 1 upon 1 plus y raised to m minus n into, again 1 minus x. In place of x we have to put 1 upon y, 1 minus 1 upon 1 plus y bracket raised to n minus 1. Again we have to put the value of dx in terms of dy, minus 1 upon 1 plus y bracket square into dy. Now our aim is to solve this integral, no problem. So take out this minus out of this integral, minus integral from infinity to 0, 1 upon 1 plus y raised to m minus n into, m minus 1 into, take LCM, 1 plus y minus 1 divided by 1 plus y bracket raised to n minus 1 into 1 upon 1 plus y bracket square into dy. So by using the property of definite integral, what is that property? Limit interchange property. Actually we have to interchange the limits. Integral from a to b f of x dx, that would be minus integral from a to b f of x dx. That means limits interchange property. So we can write 0 to infinity 1 upon 1 plus x, 1 raised to m minus 1 means 1, there is no any problem, divide by 1 plus y raised to m minus 1 into plus 1 minus 1, separate this index, plus 1 minus 1 will get cancelled, y raised to n minus 1 divide by 1 plus y raised to n minus 1 into 1 upon 1 plus y raised to 2 dy. So we can write integral from 0 to infinity. Numerator is 1 into y raised to n minus 1 into y raised 1 means it will be n minus 1 y raised to n minus 1. Again in the denominator 1 plus y raised to m minus 1, 1 plus y raised to n minus 1, 1 plus y raised to 2, means we have to use the index rule. 1 plus y raised to m minus 1 plus n minus 1 plus 2 dy. So it will be minus 1 minus 1 minus 2 plus 2, that will be get cancelled. So we will write this, therefore beta of m comma n, which is equals to integral from 0 to infinity y raised to n minus 1 divided by, in the denominator there is only power 1 plus y raised to 1 plus y raised to m plus n. Is it okay? Where m and n are the positive here also. Here we can write m and n are also positive, okay? So, in this way we can write here m and n are positive according to the definition. ते परत परत लिहायची काही गरज नाही आहे. So, hence proved. So, we can write again these properties. Again we can write these properties in this way. Beta of m comma n is equals to, similarly we can write, लक्षात येईल का रे, यालाच असं सुद्धा लिहिता येतं. Similarly we can write beta is interchange, so we can write the transformation second. 1 minute, this is the second. We know that m and n are similarly, m and n are interchanging. We know the property. Similarly, we know that we have for beta m comma n, which is equals to beta of n comma n. So we can write the second transformation, beta n comma m, which is equals to integral from 0 to infinity y raised to m minus 1 divided by 1 plus y raised to m plus n dy. So we have to write here dy, okay? So this is the property. In place of m, interchange m and n, then we will get this property, next property, okay? So up till we have seen the different properties. In terms of x, we can write this also, interchange केल्यामुळे. Also we can write in terms of x, beta of m comma n, we can write integral from 0 to infinity. In terms of x, x raised to m minus 1 divided by 1 plus x raised to m plus 1 m plus n dx. This is in terms of x. So this is the transformation of beta function. Means we can write beta function in another integral form whose limits are 0 to infinity. These are the transformation of beta function. Actually, basically the beta function is, according to the definition, its limit is from 0 to 1, x raised to m minus 1 into 1 minus x raised to n minus 1 dx. This is the basic definition of the beta function. Here m and n greater than 0, m comma n greater than 0. But we can write this beta m comma n in another integral whose limits are 0 to infinity. So beta m comma n means integral from 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n dx. Or you can write beta m comma n is equals to integral from 0 to infinity y raised to n minus 1 divided by 1 plus y raised to m plus n dy. Whatever may be you can write. याला x ला ना याला सुद्धा y मध्ये लिहिता येतं. So these are the different beta functions, okay? तर अशा पद्धतीनं this is the transformation of another form of beta function, okay? ठीक आहे. So now we shall stop here. Now the next part we will see tomorrow. शेवारे attendance पाठव.